In this class, now I am going to explain you random variables and their probability distribution. First, let us begin with a random variable. Random variable. See students, we define the random variable like this. There is a function x which is mapping from S to R is called a random variable, where S is the sample space which is associated with a random experiment, and a capital R is called range of this sample space, where x represents a random variable. For example, if you throw two coins simultaneously, we may get head head, tail head, head tail, tail tail. This is a sample space for that random experiment. Here x is a random variable which represents getting head. What it is? A random variable which represents what? Getting head. Here how many heads are there? 2. Here 1. Here 1 head. There is no head. 0. This 0, 1, 2 is the range of this random variable. What it is? This range contains either 0, no head, 1, getting 1 head, 2, getting 2 heads. This is called a range of this random variable. Here it is finite set. Whenever the range of a random variable is finite, then it is said to be discrete random variable. Sometimes this random variable may contain a value which belongs to this interval. Here 1 to 2, there are infinitely many reals are there. Okay students, here a range of this random variable is non-negative real, but in most of the applications you get here non-negative integers only, but in some applications it may take non-negative real. So here in this case, suppose in any application x may take any real from here to here 1 to 2, means here between this 1 to 2 there are infinitely many reals. Hence this variable is said to be continuous random variable. But whenever this range contains finite number of elements, then that is said to be discrete random variable. Remember this point. Now see, let us go to the meaning of P of x equal to xi, where xi belongs to the range of random variable. Here range contains either 0 or 1 or 2 na, so that you can keep x equal to 0 or x equal to 1 or x equal to 2. If you write like this, then this is said to be probability distribution. P of x equal to 0. Here x represents what in this problem? Getting head. 0 means there is no head. No head, how many times have we got? 0 number of times. So that 0 by total sample elements 4. 0 by 4, which becomes 0. Now go here. X represents getting head. Okay na? Here x equal to 1 means how many times have we got 1 head? 2 times here 1, here 1. So here what you have to write? 2 by 4. So if you simplify this, 1 by 2 you will get. Here getting a number 2. means x represents getting heads, no? So 2 means getting 2 heads. Here getting 1 head. How many times have we got 1 head? 2 times. So that I have written 2 by 4. Here how many times are we getting 2 heads? Only 1 time. So write here 1 by 4. Okay students. So here if you simplify this, what do you get? 1 by 4. Whose probability? Okay. Right. So this is called probability distribution. What it is? Probability distribution. See here, actually here 1 will come, not 0, because no head. No head, how many times have we got? 1 time. So here 1 by 4 you will get. 1 by 4, not okay, 0 here. X equal to 0 means no head. No head, how many times have we got? Only 1 time. Tail, tail. So 1 by 4. If you add sum of all these probabilities, your result would be 1. So P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. These are 0, 1, 2 range elements, no? If you add their probability, you will get a result will be 1. So this is called what? Probability distribution. This is random variable and it is sample space which is associated with a random experiment. Remember this. I hope you have got it, the meaning of a random variable and their probability distribution. See, let us observe one more random experiment. Roll a cubical dice. You know how the cubical dice is, which has 6 surfaces. On the 6 surfaces, mark 6 numericals and roll on the floor. You may get on the topmost surface, you may get 1 or 2 or 3 or 4 or 5 or 6. Now, x is a random variable which represents outcome of a die on the topmost surface. So that cubical dice may get any one of 1 to 6, no? So that represents this x value. X represents a value on the topmost surface of a cubical dice when it is rolled on the floor. So you may get 1 or 2 or 3 or 4 or 5 or 6. You can write it as x equal to xi, capital X equal to xi. So these are the range values. You know, just now we have seen the meaning of a range. Okay. So in the range of this random variable, you may get 1 to 6, any one. Now find whose probability. X equal to xi. So what is the probability of getting 1? 1 by 6. Getting 2, 1 by 6 only. Getting 3, 1 by 6. Getting 4, 1 by 6. Getting 5, 1 by 6. Getting 6, 1 by 6. So these are range values for this random variable. This, the previous one, x represents getting head when you throw 2 coins simultaneously. But here x represents what? Number on the topmost surface when the die is rolled. So on the topmost surface you may get 1 to 6. Then these are the probability values of this random variables. So this is said to be probability distribution and this is said to be random variable. If you add sum of all these probabilities, so what will be the result? So summation P of, tell me student, this is x1, this is x2, x3, x4, x5, x6. So you can say it as x equal to xi, small xi. So here I runs from 1 to 6. This sum would be 1. Remember this point. And for the same question, if you want to find mean, what do? Find the mean of this data. So you know, mean is denoted by the letter either x bar or mu. So this is the formula to find the mean of the data. Xi into P of x equal to xi, where I is running CL. In this problem, I is running from 1 to 6. So what you have to do, students? Take the product of these two, so that you will get 1 by 6. Take the product of these two, you will get 2 by 6. Take the product of these two, 3 by 6. Here 4 by 6. 5 by 6 and 6 by 6. Now LCM is 6. Now add all the numerator values. Sum of here 1 plus 2, 3, 3 plus 3, 6, 10, 15, 21. If you simplify this, so 3 7s are 3 2s, 7 by 2 is equal to 3.5 is the mean of this data. Okay. Now find the variancy of this data. Variancy. So to find the variancy of this data, so there is a formula to find the variancy. See, which you have learnt in the statistics, sigma square is equal to summation here xi square P of x equal to xi minus mu square. So here I runs from 1 to 6 in this problem, because range values 1 to 6. If you put x equal to 1, that represents this value. If you put x equal to 2, this value. X equal to 3, this value, and so on till 6. This is the formula to find variancy of this data. Okay, so that is denoted by the letter sigma square, you know that. So you can do the simplification. Here xi square means square of the random variable. So 1 square value 1 and multiply with its probability. And here 2 square 4 into its probability. And 3 square 9 into 1 by 6. 4 square 16 into 1 by 6. 5 square 25 into 1 by 6. And 6 square 36 into 1 by 6 minus mu square. Mu means average, mean of this data. You got as 3.5 whole square. Otherwise 7 by 2 whole square. Now simplify that so that you will get variance. So how do you simplify this? From all of them you can take 1 by 6 common. Inside here 1 plus 4 plus 9 plus 16 plus 25 plus 36 into 1 by 6 minus 7 by 2 whole square. 3.5 I have written as 7 by 2. Now simplify. So sum of the square is here. You can add it. 5, 9, 14, 14, 16, 30, 30, 55. So 55, 36. 55, 36, 91. Okay students, 91 by 6 minus 7 by 2 whole square. So 49 by 4. So the LCM is 12. So 91 into 2 and 4 3s are 49 into 3. Now simplify. This is going to be 182. And how much is this? 147 by 12. Difference of these two 182 minus 147. So here 12 minus 7, it is going to be 5. Okay, alright. Here 7 minus 4, 3, 35. 35 by 12 is the required variancy. Okay students, I hope you have understood this. So now let us go to one more application from this random variable. See that the probability distribution of a random variable x is given below. X equal to xi 1, 2, 3, 4, 5. Probability distribution of a random variable x is given like this, and whose probabilities are given like this: x equal to xi. K, 2k, 3k, 4k, 5k. Then find k. This is the question. Okay, and also they asked find the mean and variance. If you know the k value, then you can able to find whose mean and variance is same like previous one. But in the previous one directly there were probabilities were given, but here probabilities are not given. They mentioned as k. First you would have to find k. Then later on you can able to find whose mean and variance. Am I right students? Now let us find k. So how do you get k? If you add all these probabilities, whose sum would be equal to 1, you know that. Okay, now add it. Sum of I runs from here 1 to 5. So P of x equal to xi is equal to 1. This is the formula. Get the sum of all these probabilities. K plus 2k plus 3k plus 4k plus 5k. Now which is equal to 1. Now get all this probability sum. 5 plus 4, 9. 9 plus 3, 12. 12 plus 3, 15k. Now 15k equal to 1. Now k equal to 1 by 15. You got k value, and go back in the place of k, write this 1 by k. So if you substitute k value 1 by 5 here, it is going to be 1 by 15, 2 by 15, 3 by 15, 4 by 15, 5 by 15. You got whose probabilities and a random variable values are given, and whose probabilities we prepared. So hereafter how to find mean and how to find variance, you know, same like previous one. Okay students, so this kind of basic applications are given in this random variables and probability distribution. So in this class what did we learn? Meaning of a random variable, and about whose range, and meaning of discrete random variable and continuous random variable, and also we learned whose probability distribution, meaning of probability distribution, and how to find mean and variance of this data. So in the next class of this random variables, there I am going to discuss with you theoretical distributions like binomial distribution and Poisson distribution. So for the two types of distributions, I will take one more class. So this class here itself I am closing. Thank you one and all. I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Thank you.